So, welcome to what is hopefully the last code that I will have to show you, the last code-based lecture. Relatively short one this week, so we'll probably be done just over an hour, maybe just go all the way through and get it all done, see how we get along. Don't forget, in the practical session, hopefully you've got a little bit to say about your web applications, a few slides. If you haven't, you'll probably have half an hour to knock something together between the end of the lecture and the beginning of the practical session. Okay, so just three things to go through today briefly. PHP, AJAX, and then a little bit on what's called the same origin policy and how you get round it, which is linked to AJAX. Okay, so we'll get there. So, PHP is, as it says, personal hypertext programming language. That's what it stands for, and it's a programming language like Java, an imperative language that runs on web servers, basically. So it's a server-side imperative language. So it does the same thing that JavaScript does in the browser, but it does it on the web server, basically. It's the most widely used, I would think, server-side language overall, although I don't have figures for that. Why I say it's the most widely used is it comes ready wrapped with most servers. So Apache comes with PHP, and many other, Tomcat I think as well also comes wrapped with PHP. So PHP comes as almost a standard with web servers. It's also quite an easy language to learn and to deal with. So it's used a lot by individuals as well for building small websites, but it's also used to build industrial, large-scale websites as well. So what do you do with PHP? Well, probably its greatest use is the dynamic writing of HTML, CSS, and JavaScript from the server. So when the server receives a request, in this case, it's a request to run a PHP program rather than to return an HTML page. What that PHP program can do, it could do many things, but probably the most common thing to do is it writes an HTML page, embeds some CSS in it, and embeds some JavaScript in it, and sends it back to the user. So it basically dynamically writes a web page depending on what the request is from the user. PHP and HTML are closely integrated so that you can embed PHP scripts within HTML programs, so pages. So you can have a page which is mostly just written as HTML and there's a tiny bit of PHP inside it. You can also write, obviously you can write HTML with PHP, but you can embed PHP in HTML. We'll see these. And one of its main functions, as far as we're concerned, is we can use it to query databases. So when we stick in if we've got and to write APIs onto databases. So if we get a request we can then use that request to access database, return data to the user. Like almost all imperative languages have a similar set of commands, structures, loops, variables, conditional statements. PHP is just like that. It's very similar, supports similar functionality to JavaScript, but it has its own idiosyncratic syntax. Most languages do pretty much the same kinds of things, but they do it in slightly different ways with a different way of specifying things. So PHP has variables, arrays, loops, functions, etc., but the syntax is slightly different. I often find myself writing a program or maybe writing a JavaScript. I suddenly find myself drifting into PHP, then I write a bit of Python, then I have to debug it and sort out what language I'm meant to be writing it in. But, okay, it's also a soft type language. Remember soft typing, which means you can assign any variable, any value to a variable. You don't need to use a dim statement to specify that this variable is going to store a particular data type. And remember that these PHP programs are, when I say stored, yeah, they're stored, they're accessed on a web server and called through their URL. So they're called and run using an URL, just like you call a web page. So HTTP localhost user, I've got a program called my first PHP program.php. I type that into my web browser. It runs the program, sends the message to the web server runs the program and does whatever it does. So syntax, PHP scripts start with this less than question mark PHP and ends with question mark PHP. To have PHP code to run, every page that has PHP code in it must have, to run, must have a .php extension. So this is true even if it's mostly an HTML page, but has a little bit embedded bit of PHP. If you call it, that page with .html, I'm not sure whether it'll load the page and just sort of throw an error when it hits the PHP code and do something silly like that, but it won't run properly. What you'll need to do is give your HTML page effectively a PHP extension, then it runs through, the page gets run through the PHP parser rather than the HTML parser by the web server. Commands are not case sensitive. So the command echo, which writes something to a screen or to the output, whatever the output may be. It may be a file, it may be the screen. But we can go echo, hello world is the same as lowercase echo. It's the same as a mix written of echo. And we can use these echo commands to print or write HTML or XML. So this little command that we've got here, or little program that we called, if we called it, it would write to the, if you had a web document, what it would return is one line that said hello world, then a carriage return, then another line that said hello world, and then another line that said hello world. That's what we get in the web browser. We'll see examples. Just run through some of the syntax first. Variable names are, however, case sensitive for some reason. Why? What they decide one thing is case sensitive and the other thing isn't, I don't know, but that's just the way of the world. So variable names are case sensitive, and this is an important difference between JavaScript and PHP. All variables in PHP start with the $sign. So as soon as you see anything with dollar like that, that's a variable. It's quite a nice little rule, this, because immediately you can see where your variables are. Of course, now modern day with color coding of the syntax in the editors, that's not quite so important. But before you had this color context highlighting of code in the editors, this was a nice visual clue that you're looking at a variable. So here we can put the variable is equal to the value red. Note we end the line with a semicolon. We can do echo, we write to the screen, my car is. The dot here is to concatenate text. So in JavaScript we would have written plus, but in PHP it's the dot to connect. So it's my car is, space, dot, then we write the color, the value in the color variable, red, and then we're adding in a carriage return, new line. Then we can say echo my house is dot. Note this is capital color. Variable names are case sensitive, so this would just say my house is, and then it would have a carriage return probably, because this variable is nothing, so that would just return nothing. And my boat is, again, nothing. variables are case-sensitive prefixed with. As I said, we can embed PHP in HTML. So here we go, incredibly simple. No head there. Body, I can write today is, if I want to say hello, today is, and then tell the user what the day is. I can get the date in a particular format by embedding a little PHP script in here. Get PHP. I want to write to the screen, and I want to get the date, and this is a format, a PHP format string that defines how the date is written. Okay. Body, just shut it down, and then, have I got an example? Yes, there we go. So here we are this is phpfiddle.org, like jsfiddle.org, a similar thing, but for running PHP. And we can see here, we run that, and, oh, where's the result? I haven't got a result. That's terrible. I must have forgotten to press run. Anyway, it would give you the date. And, you know. Oh, there we go. There we go. There's the code. Ah, right. It differs from JSFiddle. I thought you get the result on the right-hand side, but you don't. You get the result in the window. There we go. Hello, today is Tuesday the 31st of January the 31st, 2017. If we wanted to change the date format, then we'd have to fiddle around with, look up the instructions for the date function in PHP and decide what the correct format string is to rearrange the date in the way we want it. Okay, so what are we going to use PHP for? Well, primarily I'm teaching you PHP so that you can write a database API. That's really the sole reason for teaching you PHP. If you decide to use it for other stuff, that's great, but this is what our main aim is to get you to be able to write an API. Mind ourselves what an API is. We've got our browser. We chuck in an HTTP request to the web server. That is going to be a PHP program which gets processed by the PHP parser. The program will create an SQL query, pump it into the database. The results of the query get returned by the database. Then the PHP program will write some kind of response. So in this case, it's going to write a JSON file, and the JSON file gets returned through the web server to the browser. So we're doing this bit here, or this bit here. It's what we're concentrating on today. So remember APIs. We can pass arguments from the client to the server using arguments defined in the URI. Yep. Name, say query equals, or search equals Great Britain or something like that. Question mark Great Britain. Our PHP program has to be able to pick up and access those variables, those arguments that are passed in the URL, so that it can then decide what to do and how to react. So how do we get those values? Well, there's a function in PHP called get, which allows you to access the key value pairs that are passed as arguments in a URL. So here we go. Here I've got my HTML page. It's written as a PHP program. It's called hello name.php. Okay, so remember this is a PHP program, despite the fact that it starts off without the PHP. The PHP program is only a small component of it. So I do my doc type, I do my head, yeah. I've got my body. My body contains, in this case, so what happened, so the PHP program, basically it's writing the doc type, it's writing the HTML to the page, it's writing the head to the page, it's writing the title to the page, it's writing this, writing that to the page. Then it runs a program which is not declarative but imperative. And the imperative, so we first of all declare a variable called name, and then we set that to equal, and we use the get function to get the arguments, and we want to get the value of the argument called name that's passed in the URL. So if we go over here and local host, I'm calling my helloname.php, my question mark to start, say I'm starting some arguments. I'm passing one argument, which is called name, and I'm giving it the value David here. So David, his name equals David. So David is got by get name. We've now got name in there, and then we can echo to the screen within the PHP script itself. We have to use echo or print to write to the screen. Outside of it, we don't. So here I'm writing hello and then my name. So when we run this program, that's what we get. Yes, I haven't typed. It's been typed into the URL. The URL, we press return. This URL gets sent to the server. The server looks to see whether there is a argument pass called name. There is. And it gets the value. It returns, this get returns the value associated. Yeah, that's what it's doing. It's looking up and grabbing the list of arguments, accessing, in this case, just one named argument off there, and then using that in the program. Yeah, good. Okay. So we're going to build a web API in PHP, written in PHP, onto a Postgres database. That's what I'm going to show you how to do. And we're going to do the country and city data in access to the country and city data in the world data Postgres database. So it's the same data that you've been using as a GeoJSON, but I've imported into Postgres in this case. Okay, so the first thing we want to do is to actually connect to the database. So build your program up sequentially from the beginning, because it's quite a complicated thing. So do one thing at a time, check whether it works, then move on to the next thing. So to connect to a database, you connect using what's called a driver program, a database driver program. Drivers are just the word we use to describe programs that we use to drive other things. Usually hardware devices, hardware, but not always. It can be software as well. In this case, we're accessing the database, which is software. But you'll have heard of printer drive. You'll be familiar with printer drivers and things like that. There are many of these out there, and PHP comes shipped with a variety of these drivers. There are also other drivers written in PHP that you might download, third-party drivers as well. They all have their pluses and minuses. We are just going to use the default Postgres raw driver that's supplied with PHP. Okay, so the first thing we need is to define our connection string to the database. And we do it here. We've got called constring. We've got the host. It's just a text string. The host equals the name of the host, the database name. You know, shouldn't need to read this out. User and the password. This is fine like this for the assignment that you're doing but this information should not be simply stored in the PHP program in the web server directory. It's a massive security hole. You're providing people potentially with access, the information they need to access your database and create havoc in there. So this is a security issue. And before you implement any database that you want to make sure you've got any security on whatsoever, you should read about where you should store these. Basically, you should store these strings in a file that's outside on your web server, but outside of the web file system there. And then you call that and sort of bring in the password information into it when needed. So it's out of the view of the web server, basically. But I'm not bothering with that. We're not dealing with security particularly in this course. But bear that in mind. This is a security risk. Then we connect to the database. We just use the PG connect function, Postgres connect function, of the Postgres driver. We pass in the string, and we can use this or die construct. Basically, this says if this PG connect fails, what are we going to do? And in this case, we're going to return a message that said could not connect, and then we append onto that string this PG last error function, what's returned from the PG last error function, which is the error code returned by the database, the PG connect. So if it has an error, if it throws an error, this is how you get that error, get the error code and access the error code so you can find out what the problem is. However, if it does connect, then we just carry on with the program, and we're just going to echo connected. And just for a tidiness, we're going to shut the connection down at the end of the program because we don't want to leave empty connections open. It's just wasteful. So we close. In this case, it's all running fine, and we just get connected. So we've now got a connection to the database. Great. So now we want to start writing some SQL and pumping that SQL into the database and getting our results out. So very simple. Connection string, link to the database. We're then going to define my query. So this is from the city. I'm just going to select all the records from the city, something city table, as simple as that. Then I use the PG query function on the driver to send the query to my database connection. Sometimes you may have several database connections open at the same time to different databases. That's why you have the database connection in here. So we send that, we pump that out, and we collect the result of that query in our result result variable. The result variable is, to be honest, I'm not 100% certain how it's formatted, but what you are provided with is a set of functions for accessing the data in the format that it's returned embedded within that variable. So if I want to know how many rows are returned by my query, I can just use the PG num rows and then pass the result into that function, and that tells me how many rows there are in the result. To be honest, I'm not quite sure what free result sort of clears out this variable. It's kind of garbage collect. I must say it's probably not required for most things most of the time, but this is like being tidy. We basically clear the result because we don't need it anymore, and then we close the connection. It's just being tidy. What do we get? 661 rows. Okay. That's all very well, but what we really want to do is to actually get the records, don't we? So we'll change these, update our script again, and in this case, we're going to loop through the records, returning the data for each record. So I get the number of rows, like I did before. Then I'm going to loop through the rows. I'm going to do this with a while clause, a PHP while clause, while loop, because I want to loop until there's nothing more to loop through. So while I'm getting a valid row from PG fetch array result. So what this does is it returns the, let me get this 100% correct, for each result, echo row city. Right. What it does is it gets the next, or the first time it runs, it'll get the first row of the result table, the tuples returned, and it will return that row as a PHP array. Then each time it runs, it gets the next row, the next row, the next row, until no row is returned. And if I want to get the value of a field in each row, then I can do the row and then use the array syntax to get the name of the field, so to speak, to return. Okay, so there we go. So onto the world cities table. I run that, I loop through, and then basically I just print each city, the name of each city, with a carriage return. Voila! We now have a list of cities online. Now, I guess you can see that all is not good in the garden. Accents, yeah, we've got all sorts of funny stuff. These funny foreign languages that cause headaches to the rest of us who have sensible languages without accents and strange bits and bobs hanging off their letters. You know, it's time for you lot to catch up with the rest of us. Anyway, having said that, I'm sure there is a richness to your squiggly letters that gives you joy. Right. We've got these things, and they look like these HTML codes and things that we've sort of seen before. Basically, I am no expert on character coding, but we know something is going on, that these are character codes, and we're going to need to do some sort of translation. I'm trying to remember how. Oh, yeah. OK. And if you look at these, and you look at this result here, and then you look at the GeoJSON file that I originally imported into Postgres, these character strings exist in the GeoJSON file, and they were supplied in the GeoJSON file. So it's not a translation error when I loaded the data into the database from the GeoJSON file. It's actually how the data is supplied. OK, so these odd characters, these odd strings, are URL special character codes. The character codes that have to be replaced in the URL because you can't put, you know, E with a grave accent into a URL. Or a space, indeed. Remember, a space is %20. So PHP has a program called URL decode, which will decode these URL character strings. However, we are displaying HTML. So we have to decode out of URI special characters and then encode HTML special characters. So we have to do two things. Decode from one system of special characters, encode into the other one. So here, instead of echoing just row city, I'm first of all URL decoding the value of city. So taking out the URL, the odd URL special characters, then I need to insert HTML special characters for the characters that need special characters in HTML. So I un-URL it, and then I HTML it. And this is the result that I get. OK, that's pretty good. OK, now, oh, I didn't include that. That looks like it all worked perfectly. The reality is that there's still some character codes that are incorrect even when you've done this. I haven't got any listed on the right-hand side. I probably should have chosen a better set. But there are still some errors in here, and I never got far as to work out how. I gave up at this point. I thought, yes, OK, so there's some other character coding problems in here somewhere. At this point, I threw my hands up and gave up. Probably there were only about 4 or 5. So frankly, I could go in and edit the database and I'd be solved. Of course, if I then had an updated cities file, then I'd have to go through and do that again. So it's not perfect, but you know, there's a time cost return, you know, cost benefit return to be considered here. Okay, so character coding. Okay, so let's put in a where clause. Oh, exciting. Okay, PHP connection. So in this case, we've got our connection, we get the city, okay, we're sticking it into a variable called string. Then what I'm doing is I'm only returning where the city matches the pass string, the name, the value passed in the argument city. In the string, notice I can put in my variable that contains the city string embedded within the like clause. So here's the string for the like for the select clause. Within that, I've got the variable which is the value of the argument city passed in the URL. Very simple, exactly the same as before. So now, notice, remember, % here, so it's going to return all, it's just the initial letters, it's an initial letter search. So it'll search those letters which we pass, and then that's the wildcard in Postgres, if you remember. It's not a asterisk, it's a %. So I can now put in my query. I pass the city is equal to LON to return all cities that start with LON. I've got 2 rows, London and Longyearbyen, whatever that is. That sounds like your way. It is in Norway. Well done, me. Yeah. Right, okay, good. Okay, excellent.
Sorry,
Yeah.
go back to?
Two.
Yeah. Where you've got $str.
$str, yep.
I thought from the way you explained it that's the letters it's looking for.
No, this is the variable. The variable, so we get the LON. The LON was passed in the URL. We put that into the variable string. The single quotes are embedded within the double quotes that act as actual single quotes within the string because that's what Postgres syntax is. The $str value is because of this dollar, PHP knows it's a variable. So it's really easy for PHP to sort of, it can pick out variables out of strings, whereas JavaScript would have more trouble doing that because the word you use could have been a name of a variable or could be used as a word. But if you use the dollar, PHP immediately knows it's a string, and then the % is just the wildcard. Yep. Okay. Okay, so we've been returning these little lists of HTML and some summary information. That's all very well, but we want an API, and the API we want to return is returning JSON data, and more specifically GeoJSON data. So we don't want to return this HTML, we need to return JSON. Now, there are several ways you can do this. Unfortunately, Postgres doesn't have a function that returns GeoJSON format as a GeoJSON feature collection from a table with a column that's a geometry table. It's there on their to-do list of things, future development. So it's on the cards, but it's not there yet. So we've got a problem in that there's no simple way that we can say to Postgres, give me GeoJSON. So we've got a problem. There are 2 basic approaches that we can take to this. One is that we get the data in in PHP, just get the fetch array result, and we could write JSON or GeoJSON formatted like how we like in PHP. There is, I think I put the instructions for connecting to KUNet and the MariaDB on the KUNet web server on the module pages. If I didn't, it should be available for the GG student through the GG student section if you have access to that, or maybe that's a first. Anyway, so I have some instructions for connecting to MariaDB on KUNet, and that's the university's sort of web server environment for students and staff to do sort of little test developments. And in that example, I've got the code, and I show you how you can write an API in PHP that basically just uses this, and once you've got the results, you write the return in PHP. In the practical instructions that I've given you, I've taken another approach, which is to actually create SQL that writes GeoJSON. Okay, not as a single function. Well, it is a single function, but it's a bit of a monster of a query. Okay. In retrospect, I'm thinking maybe I should have done the PHP method, but so both are available to you if this one does your head in. Okay, so there is this other PHP approach. Okay, but our approach is going to go to you to do everything in SQL. Why pass data out of Postgres to PHP, spend time processing it and then passing it on? Why not get Postgres to do it all for you? That's my theory, or my approach. So, what we've got to do to create our GeoJSON, what's called a feature collection, is we've got to convert our non-geometry table fields into JSON objects. We then got to combine those JSON objects into what's called a JSON array. We've got to convert the geometry into a GeoJSON array. So we've now got a JSON array of attributes and a GeoJSON array of geometries. Then we combine the JSON attribute array and the geometry array to create our feature collection. And that's what we pump back to PHP, and then PHP just sends it off back to the client. So I'm going to build this query up slowly, so I hope you'll refresh your mind and are feeling like a bit more SQL. Okay, so it's going to start off by creating our GeoJSON row of our individual JSON objects for each row. So I've got a select. I'm using the row. So Postgres has a function, row to JSON, which will turn a row into JSON format string as JSON. That's what we're returning. From, so we're getting it from a subselect, a select command, another select command, which goes to the city table and returns the FID, the object identifier called ID, the city name, and the Wikipedia. Basically, we don't want the geometry. We're getting rid of the geometry here. This is the function of this. So, and we need to return a whole row, so we get this as a row, and then we run that row through the row to JSON command. And this is what we get. For each row, we get nicely formed JSON, ID, 1, city, AJAX, Wikipedia, AJAX, Alaska. Okay, so we've now got one row in nicely formed JSON. That's quite good. SQL's done well for us there. We now need to take all those individual rows and concatenate them into an array of JSON objects. So we're taking those individual rows, wrapping them into the array. That's basically, we're sticking a square bracket on either end and comma separating the list. So there is a function called array aggregate, which aggregates, takes each row of JSON, or each row, and then will concatenate them with a comma to create a list of objects, or list of rows, the contents of the rows being listed together, separated by a comma. There's one. Then we run the array to JSON function to convert, to properly format that as a JSON array. Basically, it then sticks up in these square brackets at the end. So now we have one row, which is a JSON array containing JSON objects for each city's attributes. Okay, so we've now got our array of JSON attributes. Now we need to convert the WKB, well-code binary geometry. Remember, the geometry is stored as well-known binary in the Postgres database. We need to convert that into GeoJSON, just the JSON flavor but with spatial coordinates. Now there's a nice function here that's called st_as_GeoJSON. And when I first saw that, I thought, brilliant, that function will just do the whole lot for me in one go. No, it only does geometry. So we pass in the geometry field from city, and it simply formats it as GeoJSON. Excellent, brilliant. And that would work with geometry, polygons, lines, it just happens to be points this case. So we've now got our individual rows with GeoJSON for the geometry for each object, for each row. Well, what a surprise. Okay, so we've now got a JSON array of feature attributes and a table in which each row contains the geometry of features in GeoJSON. And we now need to combine those into a GeoJSON feature collection. So this is the final query to return our GeoJSON feature collection. It's the largest query I'm ever going to show you probably. But it works, but you don't really need to know the fine details to use this. What you need to know is where I can edit, how I can edit it to get the result I want, rather than necessarily so you just really need to learn to edit this. So basically, we wrap all these functions together into a single command. Now, I think I do break these down. So that's the full query that's going to return me GeoJSON feature collection. Okay, so let's break it down a little bit. So this section here, this returns me select feature as type. Well, feature is just text. It returns a row called type with a string feature in it. Then we do our as GeoJSON. There's our GeoJSON for that row. And here we do our row to JSON there to get the properties. So we've now got 3 columns, GeoJSON, JSON, and just the feature here. We then wrap that, turn these rows into we aggregate those rows and turn them into an array of the JSON, remember? So we've got now select feature collection type as type. So our type is now a feature collection. And we've basically turned this query into a JSON, a single JSON array. Oops. That looks like the same. Is that the same? Oh, no. Then finally, we do a row to JSON function to finish off. It turns this single row into a JSON object. It hurts my head to think how this works. Okay. So, and there is our GeoJSON feature collection. Okay, what do you need to do? Okay, so this is all very well, and it's nice if you can get your head around it, how it works. And I would advise exploring, in the practical instructions, you can do this yourself slowly, you build it up slowly, you get a better picture from what's going on than I can give you. But what you want to do is, now we've got this query, it works for cities, how do you change it to work for your data? Well, it's actually very simple. First of all, here's our where clause, where city. So we're defining what table we're getting the data from. Here's a like clause, so we can add in a like clause. Sorry, first of all, we're adding in a like clause. So before we just returned all cities. If we want to add a like clause in, well, we can just add it in under here. So instead of returning all cities, we can now do where cities like the string that was passed into us, yeah? In the URL. So we can add where clauses, and then we can simply type where city equals low, and we've now got a query, the where clause, passed into our GeoJSON. We're passing our we're doing the query with the where clause on the initial 2 letters. Yep. So we did what we did before, but it's now embedded within this large set. If we want to do a spatial API, we can build one of them relatively easily. So here, everything's all the same here. Everything's all the same. In this case, we're going to return cities and countries. So we're going to return the country for each city. So the city database doesn't have the country that the city is in, unfortunately. So, all right, the code's a bit all over the place here. But, so first of all, we're going to return data from city and country. We're going to return, we only want to return where the city is geometrically within the country. And we're passing a country name as a like string. So we're going to return all cities in countries that match the string that we pass in, or the country that matches the string that we pass in. Up here, we're going to return the LG ID. LG is the city ID, the city name, the Wikipedia entry from the city table, but also the name of the country from the country table. So this will allow us to do a spatial query on the basis of a country to return cities within a country. So in this case, is countries starting with a U. I think, did I put a wildcard? There is a wildcard in there, yeah. Country starting with a U. So in this case, my search string is equal to U. So I've got cities from the United Arab Emirates, cities from the United Kingdom as well. So those are the only two U countries there are. Those look like the only two U countries there are. Now, this is the very end, so I'll just press on and finish. I know your head's hurting now, but this is just the very end bit, and I think we might as well finish it rather than having a break, so it won't take 5 minutes or so. Now, when you're writing applications that access just local data on your local computer, there shouldn't be any, well, there shouldn't be any problems. There shouldn't be few problems. The moment you try accessing data that's somewhere else, problems start arising. And this results, the problems you're going to experience, or some of them, are a result of what's called the same origin policy. Now, I was just teaching myself this morning because I'm not, it's something that I'm not particularly expert at, but here we go. So, web browsers allow scripts that on one page to access data on another page, but only if that second page has the same origin as the first. Okay, that's the same origin policy. I'm a page here. I want to get data from this page. I'm allowed to if it's got the same origin that I have. If it's a different origin, I'm not allowed to do it. Why am I not allowed to do it from a different origin? Because this is a malicious script injection, attacks can occur. And at this point, I've waved my hands about, but nasty things can happen. So that's why they have the same origin policy. Basically, if you don't have the same origin, people can start hacking into the sensitive data and things like that. And all modern browsers implement some form of same origin policy, but how the different browsers will implement the policy in different ways and to different degrees. So this is another thing where you get one result with one browser, it work with one browser, and then somebody else will try it, and it won't work with a different browser, and it's because they have a different same origin policy, or implement the same origin policy in different ways. What is an origin, you're all shouting at me? Okay, this is what an origin is. It's a combination of the URI schema, the host name, and the port number. Now, in the description I read, they call this the URI schema, but I always sort of relate that to the protocol, but different words are used to describe the same part of a URL. So basically, this has to be the same. So it has to be HTTP. It can't be FTP or some other protocol. The host has to be the same. And the port has to be the same. Ports Are you all familiar with at least roughly what a port is? No. Okay, that's put me on the spot. What's a port? A port is just a way in and out of a computer. That's the way I understand it. So it's like having a whole load of postal boxes in your machine, in-out boxes, number 1, 2, 3, 4, 5, and in this case it's number 880. And certain programs get assigned to ports, and so each program has to communicate, or I don't know whether more than one, you tend to get a conflict if you try and use more than one program going in and out through the same ports. Basically, each program has its own ports. So, for example, PHP will listen by default on port not PHP, Apache by default listens on port 80. So if any other program tries to use port 80 to get stuff in and out of the computer, there tends to be an error because that port's always is being used by Apache. So ports, as I understand them, are just sort of pathways in and out of the computer or the processor. Anyway, these three things have to be the same to be in the same origin. Here's some examples of where the same origin policy is successful and fails, and you know, I'm going to be up front here. These are cribbed off Wikipedia, as you might be able to tell from the format. It's a very good description, actually. You know, I'm a fan of Wikipedia. All right, so here's an example. So if we're calling from, so is it the same as this? Is it the same origin as this? Well, this one is, yep. It's the same, it's HTTP, it's the same domain name, and it's because it's HTTP, it's presumably on the same port, so it's the same protocol. See, I call it a protocol, they called it a protocol here, and they called it a URI, what a schema on the other example. So it's HTTP, example.com, same port, everything's good. These are, all three are all compatible. This is just a username and a password onto the same origin. This one fails because it's on a different port. This one fails because it's HTTPS, S for secure, so it's encoded, it's a secure connection. That's not the same as HTTP, so that HTTP, that one will fail. This fails because it's got a different host. This one fails because it's lacking the www. This one's a different host. Here's an example where it depends on the browser on the bottom. There's a port difference. The port is explicit. Oh, so the port is the same, but it's explicit here, but it's implicit there. And that may or may not work depending on which browser you're on. So how do we get round this problem? Because clearly we want data from other machines. We want to be able to give data to other people on other domains, and we want data from other domains. So here's I think there's 5 different solutions here. So the first one that I've got is that you set the document domain property of both documents to the same domain, but this can result in problems by port. So when you, in your script, you could access the DOM, the document object model, find the domain property, change it to change the domain of your page to this domain of the other page, or vice versa. As long as they're the same, in theory they should work. But this doesn't deal with ports, differences between ports. You can add what's called, the server can add what's called an access control allow origin header in its response, so in the what it returns to the URL request, which tells the browser which origins should get access to the data. So if you do this, it's up to the browser to make sure that it knows whether it should be getting data from that site. So for example, we could put in, if we wanted anything from example.pom to be able to access our data through our web API, we could put a header on our file that we returned called access control allow origin, and then the name of the page or the domain that we're prepared to give the data out to. If we put a star there, it effectively makes it public. So we can make our API public by doing this, I believe. HTML5 has a new system called cross-domain messaging. I know nothing about it. It exists. It may be the future, who knows. There's also this thing called WebSocket I've absolutely never heard of before either, but the browser sends, in this case, the browser sends an origin header to the WebSocket URI, and the WebSocket server stores a list of valid URIs to respond to. So basically, it's sort of almost, it's the same as this as far as I can see, but it works the other way around. Anyway, we're not going to worry about those, just know that they exist and they might be used. We're more interested in JSON-P. So I'll just do JSON-P and then we're done. So what's JSON-P? JSON-P is JSON with padding. Now, HTML, so script elements are different from data elements in that script elements are allowed to execute content retrieved from foreign origin, because you want to grab programs from elsewhere on the web. So scripts allow cross-domain exchange of scripts, but not data, basically. So what JSON-P does, as I understand it, is it returns the JSON data embedded within a script tag. So you're using the script tag to exchange data. You're embedding the data within the script tag and sending that rather than just sending raw JSON data. And that works because it's a sort of workaround. The browser thinks it's a program, but in fact it's data. Okay, so here we've got a JavaScript program. We've got our script tag, and it's calling this URL. Okay. So basically, when that happens, so if this src tag is pointing to something that returns JSON-P, what is returned is the data in JSON format wrapped up in a function, a JavaScript function. So the browser thinks it's receiving a function, and it is, because the function is part of JavaScript, but embedded within that function basically just contains data in JSON format. It doesn't contain a program. It doesn't define a program, it defines data. So basically, you get a wrapped payload, which is interpreted by the browser. So what you get back, instead of JSON, the JSON that we've seen before, here's one object of JSON. The name is foo, and the ID is 1, 2, 3, 4, and the rank is 7. What you in fact get back is the data wrapped in a function call. In this case, the function called is called pass response. So in this case, we can call, what we do is there's a convention that the server offering the JSP service returns the origin to name the JSP function that is typically named JSP. So basically, you have a function here. What you tend to have is a callback function, a variable that an argument that you pass called JSP or callback or something, sometimes just a question mark, and then we set that equal to the function that we want to return, which contains the data. And then what we get is we get this returned by the server. You don't need, again, this is another case of where, I'm stretching my own knowledge here and, hanging on with my fingertips here. It's a question of, can you do it and use it That's the most important thing for this module. Understanding it, of course, is a great benefit, but it's hard stuff. It's not simple stuff. Okay, so here's a simple page, load remote. In this case, I'm calling the code query JavaScript. What am I doing? What am I doing? So here am I run the page. So I'm just running the script. It's an empty page. I use the jQuery, get JSON, so open the URL. I'm opening the API, the GeoNames API, country info API. That's what I'm calling. I've got my username here. And then I want it returned as JSON-P. So the format for this API is the ampersand and then callback equals question mark. And that says to the web app server, give me JSON-P rather than JSON. And then after the get JSON, then we can see there's a comma, and then we can call a function on the data, and this is the data that's returned by this callback function. And then in this case, I've just written the number of records. Okay. I don't feel I really did JSON-P justice, but hopefully a bit of work and a bit of thought will get better at it. Okay, so summary, we know JavaScript, PHP, both imperative languages. We know where they run, one's client-side, one's server-side. We can build PHP programs that allow us to access the data in our database, return JavaScript or GeoJava, GeoJSON in this case. Just little note there, as I said with the returning the GeoJSON feature collection, there are different ways to do it. So you could either do it in SQL, like I've shown you how to do it, or you could write it in PHP. Which you decide to do is purely a design decision. There's no right and wrong way of doing it unless your design doesn't deliver the functionality that you want. So, for example, if you're extracting the data out of the database, then spending the effort reformatting it in PHP, there may be overheads for doing that versus doing it, like I've suggested, all in Postgres. But in fact, it may turn out to be the opposite. It may be slower to do the PHP, the SQL query than to run the PHP. And only by trial and error would you find out which is the most efficient and whether it makes any difference at all to the performance of your application, of course. So I think that's it. Any questions? And I'm sorry about PHP. I would one day I'll understand JSON-P fully, but there we go. Okay, so we meet in an hour. We'll have just 2, 3, 5 minutes. We're not very, very informal discussion. Just see what your plans are. See what see what input we can make into them. If anything from last year, last couple of years, is really helpful because point to look at what people's plans are. I think it helps people plan what's a reasonable application to build. Okay, so I'll see you in just under an hour.